I'm Catherine de Wolf and I'm 25. I study at MIT. I'm doing my PhD in architecture and I'm from Belgium. Basically, I'm trying to find ways of lowering the carbon emissions associated with the construction of buildings. The Beijing Olympic Stadium has an embodied carbon that is 10 times higher than the London Olympic Stadium. This shows benchmarking and low carbon design are extremely important.
Did you know that 40% of the carbon emissions come from the building sector? And so far, a lot of effort has been put into reducing these emissions due to heating, cooling, lighting, and this is for the use of the building, and that's what we call operational carbon. But little attention has been given to carbon emissions associated to the construction itself. And these emissions, due to the rest of the life cycle of a building, from material extraction to construction and demolition of the building, is called embodied carbon. Now, the Intergovernmental Panel for Climate Change says that if we want to avoid extreme climate disruptions, we need to reduce carbon emissions now. And reducing embodied carbon emissions is an obvious opportunity to do so.
Therefore, a transparent, worldwide, interactive database has been created, and we are developing low embodied carbon design guidelines. We do this in 3 primary ways. First, we collect data from published life cycle assessments. Second, we collaborate with leading structural design firms. And third, we create the interactive, growing DEQO database, and we develop a design guide. So this is the interactive interface of the DEQO database, which stands for Database for Embodied Quantity Outputs. Architects and engineers can input data on their projects. They enter general information, structural information, and so on to allow meaningful comparisons of the environmental impact of buildings. So I developed a database where you can input buildings all over the world and compare them to other buildings in terms of material quantities and carbon emissions. With this database, I'm hoping to inspire architects and engineers to reduce the environmental impact of their projects in creative ways, such as these cardboard columns, or natural tile vaulting, or ultra-optimized bridges, or bamboo cathedrals. The star architects of tomorrow will be those who tackle this ecological challenge. Thank you very much.